The question says that a square coil of side 10 cm consists of 20 turns and carries a current of 12 ampere. The coil is suspended vertically and normal to the plane of the coil makes an angle of 30 degree with the direction of the uniform horizontal magnetic field of magnitude 0.80 Tesla. What is the magnitude of torque experienced by the coil? So there is a coil in the magnetic field. If we arrange the plane of coil like this, then it is making 30 degree with the direction of magnetic field. So we have to find out what is the torque on this magnetic coil. Now we know that the torque on the magnetic coil is given by NIAB, where N is the number of turns in the coil and I is the current through the coil, A is the area of the coil, and B is the magnetic field strength, and theta is the angle between the magnetic field and normal to the plane of the coil. So here theta would be equal to 30 degree because normal to the plane of the coil makes 30 degree with the magnetic field. And the area, for the calculation of area, we will take the square of side 10 cm because the coil is of shape square, and N is 20 here because there are 20 turns, and I current is given with the magnitude of 12 ampere. So substituting all those data in the given formula, we will come to a result of 0.96 Newton meter. Thank you.